Now, so we had begun looking at, now we'll continue with our discussion on elliptic curves. And I think I've shared the wrong one. Okay, now it's this one. I shared a wrong PDF. Now, so as I said, we began our discussion on the extension fields, and we had seen what an extension field is and the relevance of that, why important it is. We mentioned that if you have been given an elliptic curve, let me say y square is x cubed plus ax plus b, with just small parameters of a and b, so and a smaller mod, for instance, let's talk of mod 5. We can extend this elliptic curve to have more points than the usual points that it normally has, mod 5. For instance, if it's an elliptic curve of 9 points, you can come up with extend it to, let's say, f5 raised to 2, and come up with several other points. And these other points that we'll be getting will be in form of polynomials. Now, this is just for security reasons, because we want to deal with more points. And so doing that ensures that we have more points. And of course, polynomials also coming in adds again on the security. Now, so what we want now, this we had begun last time, we're looking at how do you then add points? How do you add points on the extension field? How do you then add points on that extension field? So that is the discussion we continue with today to see how to add and so on. So I think this example that I've displayed here, we had already looked at it. So we were to look at other examples, but let's just go through again to see what happens. So of course, we will not be doing it manually because we'll just do it manually now, since we are dealing with the smaller module. But as we progress, when you come up with a very large mod, only Rust code will help us. So that is why then we need to understand how to write it so that we can do summation of points, doubling of points, which is very important in elliptic curve cryptography. Now, so we want just to add this point P and Q, and they're defined on this elliptic curve where the parameter R is 1 and the parameter B is 1. The field is F5, but we want to extend it to F5 too. So that means now we'll be dealing with more points. But of course, how do we add points on this? So as I said last time, to add points on this, the 2 here should not distract us. The 2 here, this power 2 should not distract us. What we'll be doing, as we've always done, we'll be just doing everything, every arithmetic we'll be doing will just be mod 5. Mod 5 and not mod 25. So the 2 should not distract us. We are doing mod 5 because that was our original field. Our original field was F5. So if the original field is F5 and you're working on summation of points on the extended field, you do the summation or point doubling on mod 5, not mod 25. So that is what I wanted us to emphasize, that our summation, our point doubling, our addition of points will be done mod 5 and not mod 25. Now, this too is just the embedding degree. Of course, when I say that, you understand that it's the degree of this polynomial. So this polynomial, its degree is 2 here. And this polynomial must be irreducible. In other words, you cannot factorize it. So that is the polynomial it's not the only polynomial you can use in this case. But you have to come up with an irreducible polynomial, and that is what you then use. Now, so let's add. So adding again, we just use the normal formulas we normally use in elliptic curve. So this one we had already done, and I'll just mention as we move. What I wanted to do today is just how do we then add if the points are polynomials, not 2 and 4, 3 and 4. We want points which are polynomials. Now, for you to add, the first thing we do normally is to first of all verify that the point is on the curve. For our case, this point is on the curve, so we'll go straight away to adding. So to add these 2 points, the first thing we do, we get the slope. Of course, the points are different. So if they're different, this is the formula for the slope. But if it's the same point, again, we have the formula for the slope, and we look at that. Of course, we had already looked at it earlier on when we were doing summations on these elliptic curves. Now, these 2 points are different, and therefore the polynomial, the slope is change in y over change in x. Change in y, 4 minus 4, 3 minus 2, change in y, that is change in x. That gives you 0 as the gradient. Now, so once you find the gradient, the next thing is to find now the coordinates of the new point. Well, you see when you sum 2 points on the elliptic curve, you get another point on the elliptic curve. That's what we said. You add the 2 points on the elliptic curve, you get another point on the elliptic curve. So we then want to find the coordinate of this other new point, and we call that coordinate x3, y3. So that is what we want to find. We want to find what x3 is and what y3 is. Now, so x3 is obtained by gradient square minus x1 minus x2, where x1 is 2 and x2 is 3. And y3 is given as gradient into x1 minus x3. x3 is what we're just getting here. So once you obtain it here, then use it to find y3. Then you subtract y1. So those are the formulas that we use to find x3 and y3. So very fast we can do that. And I just want to emphasize that we are doing that mod 5, not mod 5 raised to 2, but mod 5. 5 was mod 5 was our mod on the original field. So we don't change it because we are extending. No, we don't do that. Now, so we found what gradient is, our slope. And then x2, as we've said, could be any of them. You can even interchange it, there's no problem. Let's pick this to be x2 and this to be x1. x2, x1. So x3, therefore, is gradient square minus x1 minus x2, and this is minus 5. We are doing it mod 5. That gives us 0. We are doing it mod 5. So that is 0 to us. Now let's get y3. We have the formula there as gradient into. So y3 is gradient into x1. Our x1 is 2. Minus x3, our x3 we just obtained 0. Then minus y1, we have it as 4. Now, this first bracket times 0 gives us 0. So the result here is minus 4. But remember, we are doing it mod 5. So minus 4 mod 5, therefore, is 1. Minus 4 mod 5 is 1. You just add 5 to minus 4, and you have 1. So our y3 is 1. Our y3 is 1. So the new points that you get when you add these 2 points is x, which is 0, and y, which is 1. So this is the new point. Now, verification here, I said you can verify using the code, and we did that last time. This was just a reminder of what we did. We did that. Of course, we shall again see the code later when we do the next exam. The code is here. We looked at it last time. That's the code that will give us, so that you look at, you can look at it because they are recording. Now, I had emphasized on this part. I had emphasized on this part. 0, 0, S0. So what are we writing? What is it? So what does this mean? 0, 0. 0, 0 means, you see, this thing is supposed to be polynomial. It's supposed to be something like A plus by. Let me say even bt, comma, let me say c plus dt. So this is what this is supposed to be. This is how these coordinates are supposed to look like. But now, when you see 0, 0, it means the value of A is 0, the value of A is 0, and the value of B is 0. So the whole of this first bit, this x coordinate is 0. And this y coordinate again is 0. So we had looked at that last time when you were running the code. But of course, again, we shall run the code after the next example, and you will see that. Then I'll explain how this code is working later on. Let's look at this example. Now, I'm using the same, consider the short Westerese elliptic curve that we've just mentioned above. The elliptic curve above is this, x cubed plus x plus 1. Because that A was 1 and B was 1. Now, this is one of the points. This is a point on that curve, and this is another point on that curve. So we want to sum these 2 points. So you can see these are polynomials. These are polynomials. And we say that the importance of these polynomials, again, is just to ensure that you are, there's security, just ensuring security. So the question is, if this is a point on this elliptic curve, after extension mod 5 raised to 2, if this is a point and this is another point, the question is, can you sum? Can you sum this? This is just plus. Then you check your computation using Rust. So we will sum this and then try with the same Rust we used for this other point and see whether it will give us the same sum. Then after that, this is another question, solve this. So x plus this point, can you get this point? So what is x? So if x plus this point equals that, what is x? Now the importance of this is, you see when you are doing elliptic curve cryptography, for instance, you have a message which is a word. That message, first of all, you convert to a point. After converting to a point, you may want to encrypt it. So encrypting it, and you're adding something on it. That is, you're adding something to it. And then after that, you'll have to decrypt and so on. So that is why this kind of questions then be very much important to us, because by solving this, you are able to decrypt. When you understand how to solve this, then you understand how to decrypt and how to encrypt. Because you're taking this message, which is a point, you're adding something to it, and somebody will have to subtract that something from it as a process of decrypting. And you maybe you are adding something to it as a way of encrypting this message. So that is why we need to know how to do these calculations. And of course, these calculations, after we've done them, they're supposed to assist you know, then how do you write a code that can do that work for you? A code that can encrypt for you, a code that can decrypt for you, and so on. So those are the skills that we need to obtain from this calculation. Now, these 2 points, when you look at them, they are not the same, they're different. Since they're different, the knowledge of getting the slope is as we've done in the above example. So I'll first of all do this part. Then we counter check using Rust code. So this, we can take this as a one question. This is another question. Another question is, if you're given x plus this, can you find what x is? Again, we'll do this and see if we can counter check again using Rust code. Then finally, this is another question. Question 3. Can you multiply 5 by this point? This is just a point. Can you add it 5 times? Can you add it 5 times and get the result? And again, we counter check. After doing that, we counter check using Rust code. So those are 3 questions that I want us to look at today, if time allows us. Okay, so let's begin the first question, where we're supposed to sum this and that. Now, I've begun by is on the elliptic curve. So let's do that. Of course, I know this point is on the elliptic curve, but I feel that verifying will again assist us. We'll get to discover some concepts here and there. So verify the points are on the elliptic curve. So to verify that they're on the elliptic curve, want to put the value of x. This is the value of x. Want to insert the value of x here, where there's x cubed, and then here, of course, we know that a is 1 and b is 1. But what we just want to substitute x here, the value of x for this point. This is x, and its y is this. So if you are to put x here, and put x here, and put y here, will the right-hand side be equal to the left-hand side? That is what we want to do, just to prove that the point is on the curve. So I'll do that, and then I'll do for the first point, and for the second point, we can skip because it's the same process. Now, so I want x cubed. I want x cubed. But my x is this, 3 plus 4t. So first of all, I get x squared. Then x squared times x, of course, gives me x cubed. So what is x squared? When you square this is 3 plus 40 multiplied by 3 plus 40. So when you do that, you're getting 9. And 3 times that, you're getting 12t. And then 40 times 3, getting 12t. And then 40 times that, we're getting 16t squared. T squared. Collecting like terms, you have 9 plus 24t plus 16t squared. But now, what will help us here is the polynomial that we are using. This polynomial, t squared plus 2 is 0. That means t squared is -2. And we are doing it mod 5. So -3 mod 5, you can even call it 3. No, -2 mod 5 is 3. So where there's t squared, like in this case, you're putting 3. So then you have 9. Oh, it's mod 5. 9 mod 5 is 4. 9 mod 5 is 4. And then 24 mod 5 is another 4. Then 16 mod 5 is 1. But the t square is 3. T square is 3. This is 8 plus 3, which is 11 mod 5. This is 1. No, I forgot some t somewhere. I forgot some t somewhere. This is 24, it's 24t, it's 40. It's 40. So 4 plus 3 will be 7 plus 40. But 7 mod 5 is 2 plus 40. I think there's, just relook at it. Look at this one first of all. Okay, this is now okay. This is now okay. This is now clear. 9 is 4. Yes, 9 is 4. 24 is 4t. Yes, that's okay. But this one, 16 is 1. We are doing it mod 5. And t squared we found 3. T squared we found 3. So I'm looking at this and I'm discovering that in my working, I forgot t squared at this point. That's why I'm trying to see if they get to be the same, but I've noticed that this was 16t squared, but then at this point, I forgot the t. I did not write the t there, the t squared. So that is why I'm getting them to be different. So this will be 7 plus 40, but the 7 mod 5 will be 2 plus 40. So this one, let us remember this, it's 2 plus 40. It's supposed to be 2 plus 40. I hope you've seen that. I had omitted the t, so that means it will affect some of our workings down. It will affect some of our workings down. But the rest is okay. So when you're typing, sometimes it's that tendency to forget. So I can say just drop to the t-square. So when you drop t-square, this one and that becomes 20. And modify if it gives you 0. So that's how I got to 0, but it's not correct. It's supposed to be 0 because we know that mod 5, 16, of course, this is just like 16 times 3. 16 times 3. Now, it's not a must that t-square must be 3. T-square can even be -2. We had defined -2, and then we said -2 mod 5 would be 3, but it's not a must. Because at this point, what we would have done, even using this, would have been 4 plus 40, then 16 would be 1, -2. And so when you collect like terms, this -2 and that will give you 2, then plus 40. So you would still get it. So it's not a must that every time you must convert it to positive. You can still use the negative, but the final result, ensure that the final result is positive. Now, so we found x squared. Now to get x cubed, you take x times x squared. So we'll have a problem because of this. We'll have a problem because of this 2 supposed to be, this 0 supposed to be 2. Now let's multiply again. 3 times that will be 6. This is a 2, this is a 2 here. So 3 times that will be 6, then 3 times that will be 12t. Then 4 times this will be 8t. Then 4 times that will be 16t squared. 16t squared. Let's just go through again. That will be 6, and then 12t, and then 8t, and then 16t squared. Now, but this one is 20. This one is 20. Mod 5, that will be 0. So then we have 6 plus 16t squared, which is, of course, this is 1, mod 5. 6 is 1. And 16 is another 1, mod 5. And t squared was 3. So the result here is 4. The result there is 4. So that means y cubed is 4. Y cubed is 4. No, x cubed. X cubed is 4. So I'm just hoping that I've done it correctly, especially the first bit. The first bit when I was getting a 0 here, just hoping that my working was correct. This time I've gotten 2 plus that, and then I have 4. I have 4. So you can see again, it's different. It's different. I'd gotten 2t plus 3. Of course, we will confirm later using our Rust code. But that is x, no, not x3, it's our x cubed. That is our x cubed. So now we have to now put it here. X cubed. So instead of this, we have 4. Then x is this, 3 plus 40, then plus 1. So this gives us 7. These are 7. 7 plus 1 is 8. 8 mod 5 will be 3. be 3. And this is 40 plus 40. So that is the value of x. And this is the right-hand side. This is the right-hand side. So the right-hand side gives us that. So now we try the left-hand side. When you try the left-hand side, y square, our y is this. Our y is 4 plus 3t. So 4 plus 3t, when you square, you have that, 16. Then 4 times that will be 12. We had already done that, of course, it's the same thing. This is 4 plus, this is 4 plus 3t. This is a bit different. So 4 times 4 will be 16. 4 times 3t will be 12t. Then 4 times 3 will another 12t. Adding gives you 24t. Then 3t times 3t will be 90 square. Now, at this point, 16 is 1. And then 24 is 4t. And then t square was 3. So 3 times 9 will be 27. So when you add this, 27 plus that will be 28. 28. And then this is 40. Now 5 into 28, the remainder will be 3. So coincidentally, the value of y that I've gotten, y square, is the same as the x, the right-hand side that we've got after correcting. So it means when I was doing, I did not counter check this and this because I was not, I saw the 2 and I thought it was 3. I would have noticed at that point. So that means our correction is correct because it's now agreeing. Our corrected value is agreeing with our y square value that I obtained earlier. But the initial one was not, they were not agreeing. I did not realize that these two were not equal. When I saw the 2 and saw the 3, I thought they were the same. But now the corrected value has given us this value as 3. So we are now correct. Now, so that means that the point is on the elliptic curve. The point that we are dealing with is on the elliptic curve. So I said I'll only test one point, and you can test the other point because of time. You can test this, whether it's on the curve, but we've seen this. So it's the same way, doing it the same way. Now, so once you verify that the point is on the elliptic, these points are on the elliptic curve, we now proceed and add them. We now proceed and add these 2 points. So that is what I want to do. So I want to skip the verification of the other point, and I come straight to, but I can scroll slowly because of recording, so that if you miss to verify, you can always confirm with mine. So from here, we are verifying if that Q is on the elliptic curve. And so we begin by, we want to see whether this X value, if you are to substitute on the right-hand side, and then this Y value substitute on the left-hand side, whether the two will be equal, whether the left-hand side and the right-hand side will be equal. So that's what we want to do. And then you'll do it later and verify with this. Now, so after the verification, therefore, you're supposed to add the 2 points. And since they are different, we are using this formula for finding the gradient, change in y over change in x. These are the points, so the y2 and the y1 value. We have the x1 and the x2 value. So y2 minus y1 will be 3, that is y2, then minus y1, which is 4 plus 3t. When you do this, so this is the change in y. This will be negative 1 plus 3t. But remember, negative 1, we are doing this mod 5. So this will be 4 plus 3t. 4 plus 3t. So this is the change in y. What about change in x? X2 minus x1. So our x2 is 3. And the x1 is 3 plus 40. So when you subtract this, 3 minus 3 minus 40. So 3 minus 3, of course, is 0. And then you have minus 40. And so minus 40, you can write it in terms of okay, this one, you can write it as positive. You can write it as a positive number. So how did I get this? What was the x1? X1 value. Let's just go back. X1 value. Okay, x2 value. X2 value. Oh, no. What I've done is not, I did not extract x2 value correctly. I did not extract x2 value correctly here. So let me again see what the x2 value is. Our x2 value is this. No, where is that? Is this. Our x2 value is 3 plus 3t. Then our x1 value is 3 plus 40. Yes, this is now correctly extracted. So this will be 3 plus 3t, then minus 3 minus 40. So 3 minus 3 then will be 0. And then 3t minus 40 will be negative t. And we are doing it mod 5. This becomes 40. Becomes 40. So what is our gradient, therefore? Change in y over change in x. That is our gradient. Change in y over change in x. We've just obtained what our change in y is and what change in x is. Our change in y is that, and our change in x is that. Now, this is the gradient. But what you realize, our gradient has a denominator. So what we normally do in such a case, if you had something like 4 out of 7, we normally discover that this is the same as 4 times the inverse of 7. Times the inverse of 7. So that's the same thing we want to do here. I want to say that this gradient is the same as 4 plus 2t multiplied by the inverse of 40. Multiplied by the inverse of 40. So then it means we must use the extended Euclidean algorithm to find the inverse of 40. And that is a very interesting part. It's very interesting how we do that. Not necessarily directly using the Euclidean algorithm, not exactly, but I'll show you how to do that. Now, you only need to understand what inverse of a number means. When we say that a number is an inverse of 40, it means that number multiplied by 40 would give you 1 mod 5. Because we are doing it mod 5. But the inverse of 40, we've already said that points in this case are supposed to be in the form, a plus bt. Supposed to be in this form, a plus bt. So x is supposed to be in this form. So we just multiply, therefore. So we let x be this, we let x be that. And so when we let x be that, it means we want to find that x. So that means we shall find a and b. Once we find a and b, it means we have the x. So that we have a plus bt giving us 1. Now, so this is very easy. Just multiply through. You have 4at, and then you have 4bt squared is equals to 1. But what is interesting is the right-hand side. Look at this. This is 1. You see, this 1 is the same as, let me just show you. It's the same as 1 plus 0t. It's the same. It's the same because we are writing it in this form. We are writing every point in this form. So when you write it in this form, it will be 1 plus 0t. So that means we can factorize the left side. When you factorize the left side, t is common. So t is common. You would have 4a plus 4b t is equals to 1. Now, so the left-hand side, when you look at it, you discover that there is no constant. The values there, all the values have t's. So it means, again, the left-hand side, if you are to write in this form, it's supposed to be 0 plus 4a plus 4bt, or just a minute. I've remembered we are dealing with the polynomials, and so we can substitute for t square. And substitute t square first before we proceed to make our work easier. And substitute t square. Our t square was 3. Our t square was 3. So this is 4at plus 4b, 3. This makes our work easier. That will make our work easier. So then we have 4at plus 12b is equals to 1. But 12 mod 5 is 2. 2b is equals to 1. So I've said this right-hand side can be written this way. So what that means is that we have 4at plus 2b is equals to a plus 0t. So then you equate the like terms, those that have, this is 0, those that have t's and the constants. Equate those that have t, so you can see that this one has a t, that has a t. So you can equate 4at is equals to 0t. T cancels out, and you find that a will be 0. You find that a will be 0. So when you make a the subject of that formula, then you can also equate the constants, those without t. 2b is 1. So that means b is a half. B is a half. But we don't want to deal with fractions. We are doing this mod 5. So we are asking, what is the inverse? Because a half is the inverse of 2. What is the inverse of 2 mod 5? A half is the inverse of 2. So this will be 3. That will be 3. So b is 3. Now, what about x? This was our x. Our x, therefore, is a, and our a is 0 plus b, 3, then t. Of course, you can just write it as 3t. So this is the inverse of 4t. We're looking for the inverse of 4t. We're looking for the inverse of 4t. So we just found the inverse of 4t was x, and that x is 3t. Now, so slowly you go through this video slowly and get the concept there. Get what we've done at that point to get 3t, how we arrived at 3t. Of course, we began by finding the slope, and we discovered that our slope had a denominator, and so we were not able to solve it without finding the inverse of the denominator. So then we thought, let us first of all find the inverse of the denominator. And so the inverse of the denominator then becomes 3t. Now, so those are my workings. Of course, I had typed my workings here. It could be a different approach, but finally, you come to arrive at the inverse of 40 as 3t. The inverse of 40 as 3t could be different, a slightly different approach, but that is the reasoning. The inverse of a number is another number b, which if you multiply a by b, you get 1. So that is the strategy that whichever method you take, as a strategy that you have to employ and arrive at the inverse. Okay, so you look at again what I had typed and compare with what I've just done as you try to comprehend. Now, therefore, we go back to our gradient. Go back to our gradient. It's from there that we began looking at the inverse. So what is our gradient therefore? This was our gradient. So our gradient lambda is therefore 4 plus 2t multiplied by the inverse of the denominator, which is 3t. And this is 12t plus 6t squared. And this is same as 2t plus 1 multiplied by 3, because t squared is 3. So then the gradient is 2t plus 3. This is the gradient. So once you have the gradient, you want to find x3 and y3, which are now the coordinates of the sum. When you get the sum gives you another coordinate. So we've just discovered, I've just found our gradient. So once you have the gradient, you want to find x3. x3 is the gradient square minus x1 minus x2. And then what about y3? y3 will be gradient into x1 minus x3, then minus y1. So that's what we just do here. That's what we do. First of all, I began by finding lambda square. I began by finding lambda square. So that after I found lambda square, then I just insert it in the equation. This is my lambda, 2t plus 3, square it, 2t plus 3. Okay, so this will give us 4t squared. And this will give us 60. And this will give us 60 again. So 60 and 60 is 12t. Then 3 times will give us 9. Okay. So, but remember, our t square is 3. So 4 times 3, then 12t, then 9. So this is 12, and this is 12t, and then 9. Okay, you can reduce, but I decided just add first of all to get 21 plus 12t, then 21 mod 5 would be 1, then 12t mod 5 would be 2t. So this is our lambda square. So now once you have lambda square, put it in the equation of getting y3, no, x3. Put it in that equation to determine x3. So determine x3 is supposed to be this, but now where there is y, lambda square is 1 plus 2t square. This one is supposed to be square here. 1 plus, no, we've already squared. We already have lambda square. We already have lambda square is this. So this is our lambda square, then minus x1, then minus x2. Now let's just deal with the constants. 1 minus 3 will be negative 2, then negative 2 minus 3 will be negative 5, which we have here, negative 5. Let's now deal with those of the t's. 2t minus 4t will be negative 2t. Then negative 2t minus 3t would be negative 5t. So doing it mod 5, you have a 0. So x3 is 0. What about y3? We already have our gradient from above. So y3, what is our gradient? We had our gradient as this. This is our gradient. So our gradient into x1 minus x3. x3 is just to obtain 0, but x1 is this. So whatever is in the bracket is just 3 plus 40, then minus y1. So this is where you arrive. This is where you arrive. So I decided to multiply the left side first. Multiply this. That'll give you 6t. And that'll give you 8t squared. So I have 6t, then 8t squared, and this is 9, and this other one is 12t. So 6t plus 12t, oh, I didn't add here, so okay, they're here. 6t plus 12t will be 18t. And then I have 8t squared. What was t squared? T squared, was it 8 really? Huh? Let me see. How come? Where is this 12 coming from? Just erase so that I can see clearly. Okay, whenever there is a mistake, we can always correct. Whenever there is a typo, because sometimes I do it first on a piece of paper, then I begin typing. Okay, let's again do it. It will be 60, which we have. Okay, this will be 8t squared. 8t squared. And this will be 9 and then 12t. 9, then 12t. So this is supposed to be 8. 8t squared. Okay, let's see whether the final answer is correctly typed. Now, so 6t plus 12t, that will be 18t. 18t. 6t plus that will be 18t. Then what about t squared? This was 8. So it will be 3 t squared. But t squared is 3. That gives you 9. And there is another 9. That gives you 18. Mod 5, that would be 3. Mod 5, that would be 3. 18 mod 5, that would be 3. So as I told you, sometimes when there's a typo error somewhere, but the final answer is correct. So it's 3 plus 3t. So you go through, you're going through with a video of course, and then you see correct along the way. Now, so we've just obtained this. And that was this part. Now we have to subtract this part from it. That's what I'm doing here. So 3 plus 3t minus this part. So you just open the bracket. It will be 3 plus 3t minus 4 minus 3t. So 3t from 3t will be 0. But this other part will be negative 1 mod 5, that is 4. Okay? So finally, we have the value of y3 as 4. And we had obtained the value of x3 as 0. So that means, therefore, the sum of these 2 points is 0, 4. Okay, so let's just now use our code and see what our code gives us. It's the same code we used for the others for last time. Okay, so last time we had 2, 4 and 3, 4. That the previous example. And I think the answer was 0, 1. Let's just see. The answer 0, 1. Yes, P1 plus P2, the answer is 0, 1. Because we are adding 2, 4 and 3, 4. 2, 4 and 3, 4. Now 2, 4, look at what this one. You see the first coordinate is the x value. And the x value, so the x value is supposed to be in terms of, this is how it's supposed to look like. Let me just write it here for you. It is 2 plus 0t. That is why it had 0, 4. No, 2, 2, 0. 2, 0. So the 2 is this constant. And then 0 coefficient of t. This is the x coordinate. And the y coordinate is 4 plus 0t. So this is the y coordinate. So this is our coordinate. So this is then how we write it here. The x value of the coordinate must have a constant, then plus a coefficient times t. Then the y value must also have, the y coordinate must also have a constant plus a constant times t. So that's how it should be. Now, so the points we are adding here, the example that we've just done, let me just copy what the point is. The point is 3 plus 40. 3 plus 40, let me just write it here. Write it on the code. So it is, the point is 3 plus 40, comma. And then what about the other one? The other one is 4 plus 3t. 4 plus 3t. 4 plus 3t. This, we are adding this to, again, let me copy this point. The x value is 3 plus 3t. The x value is 3 plus 3t. 3 plus 3t. And the y value is 3. The y value is 3. Now, so I'm writing here so that it becomes easier for me now. As I put it here, you understand what I'm putting. So I want to put the x value. The x value here, it will be 3. And instead of 0 here, I have 4. Then the y value for the first point, P1, the y value at this point is 4, and at this point is 3. So I've entered point P1. Now let's enter point P2. This is our point P2 here. I have 3 plus 3t plus 3t. Then the y coordinates, I have 3, but the coefficient of t is 0 because there's no t here. So let me now remove this and run the code. So when you run the code, you can see what it has given you. It has told you what P1 is, because you entered them correctly. And what P2 is, we entered them correctly. And then the sum is 0, 4. And that's what we got when we did manually. Our manual calculation gave us 0, 4. That's how you do it. Now, you understand this code. This code can do all the first example and now the second example. But this second example had points in polynomial form. The first one did not have points in polynomial form. But when you are entering it here, you have to understand it's supposed to be in polynomial form. So this is the same code we looked at last time. Same code last time. So I'm just scrolling so that as you watch the video, you can also follow it. And follow it. Okay. So let me share the slide again so that we I don't know whether it's this one. I think it's this here. Okay. Now, so the next question was, if you are given x plus this, can you find what x is? Now, this is a very easy question. For you to find x, you only need to understand that this can move to the other side. So x will then be 3, 4 minus 3 plus 3t, then 3. 3 plus 3t, then 3. Now, but we don't know how to deal with minus. We know how to deal with the plus. When we deal with plus, we have to understand that minus here implies the inverse of this point. Implies the inverse of this point. In elliptic curve, we said if you have point xy, the inverse of this point is x minus y. The inverse is that, x minus y. So, what that means, therefore, this is the same as 3, 4, plus the inverse of this, which is 3 plus 3t, then minus 3. Minus 3. So that's how we do that. That's why I arrived at this. In fact, I was explaining that, and I was saying that an additive inverse of this curve, this point, will be given by that. So this then becomes that. I don't want to go into this addition, the way we've been doing it manually. I just want to go to the code straight away and add these 2 points and find the value of x. That's what I want to do. Just going to go to the code straight away. Because how we add manually is the same way we've done in the previous example. But of course, what is this? What is this negative 3? We are doing it mod 5. So negative 3 will be 2. So instead of writing negative 3, then you'll be writing it that way. So that we can now go to the code, and when you go to the code, this is the point we are entering. So this is the summation we're supposed to be doing, therefore. So this summation is supposed to give you x. This summation is what's supposed to give you x. Now, the only thing I can explain maybe is how we get this gradient. And the most important part of this is that our gradient will have a denominator. And so we proceed as we proceeded earlier to find the inverse of the denominator. So that is the only point that I think might not be very clear. And so I want to repeat it so that it becomes clear. So change in y over change in x, our y2 and our y1. So the change in y will be y2 minus y1. Y2 is 2 and y1 is 4. That change is negative 2 mod 5, that would be 3. What about change in x? x2 minus x1. x2 is this, and x1 is 3. So x2 minus x1 would be x2 minus that. So that gives you 3t. So you arrive at this gradient. You arrive at that gradient. So this is the same as 3 multiplied by 3t inverse. So this is the part I said I want to again explain. How do you get this inverse so that it becomes clear? But the rest is clear. Now, to get the inverse of 3t, we have to understand that we want to find a value which, when multiplied by 3t, would give us 1. That's what I mean by inverse. So we want to say, let the inverse of 3t, let 3t inverse be x. But x in this question is supposed to be a plus bt. Supposed to be a plus bt. Supposed to be a plus bt. Okay. Okay, I used x plus yt. There's no problem. Let's use a plus bt. So what that means, therefore, when I take 3t and multiply it by a plus bt, I'm supposed to get 1. That is what it means. Expand. When you expand, you have 3at, just multiplying, and this will be 3bt square is 1. And recall that t square is 3. So you have 3at plus 3b, 3 is 1. So then we have 3at plus 9b is 1. We are doing it modified. 3at plus 4b is 1. Of course, this one, we had already said in the previous example that it can be written as, the one here can be written as 1 plus 0t. So it's at this point that you equate the like terms on both sides, which means equating, you'll have 3at equating it to 0t. When you do this, you would find that a is 0. You find that a is 0 when you divide t and then find a will be 0. Then you will also equate 4t and 1, no, 4b and 1. So this will mean that b is a quarter. We are doing this mod. We are doing this mod 5. What is a quarter mod 5? So that is a question. What is a quarter mod 5? So what is a quarter? A quarter, let's say a quarter is m. Let's say a quarter is m. And we are doing it mod 5. So it means, what is m? What is m? When you cross multiply, m is a number which, when multiplied by 4, gives you 1. Mod 5. Which number is that? When multiplied by 4 gives you 1. You can try mod 5. We have very few numbers. We have very few numbers you can try. 0 times 4 will be 0. So if m is 4, so no, if m is 0, 0 times 4 will be 0, so it's not 1. But if you continue, you'll find that 4 times 4 will give us 1. That means m is 4. Mod 5. That means m is 4. So this is the same as 4. A quarter is 4. mod 5. But what was x? X was a plus bt. So x is a plus bt, which is 4t. That is our x, 4t. And so when you follow, you would find the inverse as 4t. So the inverse is 40. That's what I was getting, 4t. Now, so we'd said that the gradient would be 40 times. We'd found the gradient lambda. We'd found lambda. What was lambda? Let's go back. Okay. It was supposed to be 3 times 3t square, no, 3t inverse. But this is 3 times 3t, not 40. Just found this inverse is 40. So this would be 12t, which is 2t. Mod 5 is 2t. So that's the only part I wanted to emphasize. That is the only part I wanted to emphasize, how to get gradient, because I knew that the denominator will be there. And so when the denominator is there, how do you proceed to get the inverse of that denominator? But the rest of the work follows as we did in the previous exam. And so I just wanted that this question we can do it using the code, because we already have the code. So it's just keying in those values to the code. And when you key them to the code, you get the exact value of x. The exact value of x. Okay. So when I did this, I found x to be what? This was the value of x. This was the value of x. So you do it later. I think that is enough for today, so that we meet, is it on Thursday? Yes, Thursday afternoon, and look what other concepts. But you look what, we've not added this one 5 times. You can do it later on. And that this is, at this point, when you're adding it to itself, you're using a different formula, a doubling, which we know the formula for doubling a point. Of course, I've written it here. The formula is there when you're doubling a point. So you try later. So you're finding this plus itself. That means you've done it twice. You get a 2p. Then when you add p to this, you have 3p. When you add p to 2p, you have 3p. So adding p to 2p, you do it the same way we've done in the previous example. And it's not a very long thing. You find it's short. It's only that I was trying to explain many things. You have 3p. From 3p, you want to get 4p. And then from 4p, you want to get 5p. By just adding p to it as you continue with your calculation. So again, this is the 5p. So you try that later, slowly by slowly, and see whether you get that result. Thank you.